Hey class, today what we're going to talk about is direct variation. And these are kind of similar to lines, um, but there's no y-intercept. So direct variation, it's a function of the form, and you're going to see this equation a lot, y equals k times x. So this is going to be very similar to your form of y equals m times x plus b, but if you notice there's no b, k is kind of similar to the slope. But in direct variation, there's a specific name for this k, and for k is not equal to 0. And this k is called the constant of variation, and it is the coefficient of the x, as you see in our formula. So this is the constant of variation. So the constant of variation, that's just what we're going to multiply the x by, whatever the x is, and it's going to give us a relationship with the y. So what we say is the variables y and x are said to vary directly. And whenever you see word problems, whenever you see these are your keywords, vary directly, that means you're going to use this formula. And when we graph this function, the y-intercept, remember that it said it was like plus 0, so our y-intercept is going to be 0. There's no y-intercept, so everything starts at the origin, and we just follow our slope. Alright, so let's do a few examples. So example 1, we have our equation. Now the first thing you want to check is if it's actually in the form, so y equals k times x. So it looks like these are in the same form. So this is saying that k is equal to 3. So my constant of variation is 3. Whenever I graph this, this is the same as 3 over 1. So remember your slope is rise over run. So I'm going to rise 3 and run 1. These are both positive, so that means I'm going to rise in the positive direction and run in the right direction. So I'm going to rise 3, run 1, starting at my origin because my y-intercept is 0. Then I can also do go down 3, left 1. And that's going to give me my line. I do the same thing over here. Check to see if it's in the form y equals k times x. Now if there's no number in here, it's implied that it's a 1 in there, so my k is actually going to be negative 1. So that's what I'm multiplying by. Start at my 0. Now this is negative 1 over 1, so that means I'm going to rise negative 1 and go right 1. So negative 1, right 1, or I can go up and left, and then I see that that is going to be my graph for this equation, y equals negative 1 times x. Alright, you may be asked to tell whether an equation is direct variation, and then if it is, you're going to find the constant of variation. So the first thing you want to check is to see if it's in y equals k times x. This one automatically in that form. So we say that k, it says find the constant of variation. Remember, constant of variation is k, so my k is equal to 2. So your answer for this one would be a yes, it is, and my k is equal to 2. Alright, for this one, remember that I'm getting y on one side and everything else on the other. So I got to do that to this because we can't really tell just by looking at this that that is direct variation. So first thing I'm going to do, I got to get my 2x away from my y, so I'm going to subtract 2x. Subtract 2x. Now these are not like terms, so I cannot combine them. So I'm left with 5y over here is equal to negative 2x plus 1. And then I divide both sides by 5, divide by 5, divide by 5. So what I'm left with down here is y equals negative 2/5 x plus 1/5. Alright, so remember this doesn't have my y-intercept as 0 for a regular direct variation equation, but if you notice this, my y-intercept is 1/5, so whenever it has a y-intercept, that means it is not direct variation. So this is not a direct variation equation. And then for this one, I need to get my y equals k times x. So I need to get my y by itself. So what I'm going to do is I'm going to take this divide by 6, divide by 6, so I get negative 2x equals y. And if you're really picky, you can switch those around. So I got my y equals k times x. So then that is a yes, that is direct variation, and my k is equal to negative 2. So that one is direct variation, and my k is negative 2. You just got to do a little bit of algebra for that one. All right, now you may be asked to do a direct variation equation that includes the given point. So remember my equation. Cannot forget this equation for direct variation. So what I need to do pretty much is my y and my x, I need those in my equation just like I had earlier, but I need to figure out what k is. So I can't finish my direct variation equation without knowing what k is, but I have a point. So I know what my x is and what my y is, and so I can sub those in, figure out what k is equal to. So I'm going to sub in my y, which is 5, my k times 1. Now this, I need to solve for k, so divide by 1, divide by 1. So I know that 5 is equal to k. So now I can write my equation, y equals 5 times x. So that would mean my direct variation equation that runs through the point 1, 5. Do the same thing over here. Start with my equation, y equals k times x. So I start there, plug in my values. So I've got 10 equals k times negative 8. Okay, I got to solve for k. So I'm going to divide both sides by negative 8. Divide by negative 8. You can either convert this to a decimal or leave it as a fraction or reduce your fraction. I'm going to just leave it alone. So that's 10 over negative 8 equals k, which I'm fine with you leaving it like that. So y equals 10 over negative 8x. Now if you did want to reduce it, this could be the same as 5 over negative 4. Or if you wanted it in decimal form, that's negative 1.25. So any of those three answers I will take as your k, because they're all equivalent. All right. Okay, so now we start getting into the trickier ones. So with this, we're going to assume that y varies directly with x. So varies directly, so that means I'm going to use my formula, y equals k times x. So I got my formula. And what this is a two-part question. So it's saying if y is equal to 28 when x is equal to 7. So that's a relationship that we know. I don't know what k is, so I want to figure out what k is. Then I can use that k to then solve for when y is 52, I need to figure out what x is. So I do just what I just did. I know that my point is my x is 7 and my y is 28, so I'm going to sub those in. Equals k times 7. Okay, then I'll solve for k. Divide by 7, divide by 7. So that's 4 is equal to k. So now I have my equation for this relationship is that every time I have an x, I'm going to multiply by 4, and that gives me what k is equal to. So now I can use this equation to figure out this relationship. So I know that y is equal to 52. Sub that in. 4 times x. I don't know what x is, but that's what I need to solve for. So divide by 4, divide by 4. So 52 divided by 4 is 13. So x is equal to 13. All right, so that's that type of question. Anytime you see varies directly, you're always going to start with this equation. Now on to your favorite part of all math classes, the word problem. All right, so in this word problem, we've got these airships that are kind of like blimps, and they have a certain volume. The bigger they are, the more they can hold. So the first one that was built in 1852, it was 88,000 cubic feet. That's what the volume was. And so then if it was that big, it could